Good morning, friends. So, in the series of KMAP, last video I have talked about reduction of KMAP using SOP and POS form when function is given in the form of variables. But here the function is given in the form of min terms and max terms. Now, how we will reduce this function using the KMAP? So, for this particular example, example number one, we have min term here. We have min term here, and here we have max term. So for max term, I will deal up, can say next video, but for this video, I am discussing about the min terms. So first of all, we have to find what should be the number of, can say boxes in the KMAP. It is decided only by the maximum, can say min terms here. Here maximum min terms is 15. So 15 cannot be represented by 3 bits. So 15 minimum we take 1, 1, 1, 1. 4 bits are required. If 4 bits are required means I can say 4 variable KMAP is required. 4 variables KMAP is required. 4 variables KMAP is required. So for this particular size of KMAP, we have to look at the maximum value of min terms. It is a 15, so 15 can be represented by 4 variables. That's why we have to draw 4 variable KMAP. For 4 variable KMAP, okay, yes. Yeah, this is the 4 variable KMAP. So there will be 16 boxes. For 4 variables, boxes equal to 16. Okay, boxes equal to 16. There are 16 boxes for 4 variable KMAP. Okay, so 4 variable KMAP means boxes equal to 2 to the power 4 means 16 boxes are required. 16 boxes are required. So it is AB and CD. Means 4 variables will be there A, B, C, D, and 16 boxes are required. For this particular 0, 0, 0, 1, 1, 1, 1, 0. And so same 0, 0, 0, 1, 1, 1, and 1, 0. So if I do the numbering of the boxes, so accordingly you can do the numbering here. This box is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So this is the numbering of the boxes. Now we have to fill the one at the place where the min terms are available. We have the min terms 0, 1, 7, 8, 9, and 15. So we have min terms, simply mark the min terms. Or I mean to say, simply put 1 there where the min terms are available. So at 0, okay, 0, 1, 7, 8, 9, and 15. So these are the possible boxes where we have to put the 1. So we'll simply put the 1 here. Okay. So now I am redrawing it. So this is KMAP of 4 variables A, B, C, D, A, B, C, D. So here we have 1. Here we have 1, 1, 1, 1, and 1, 1. Rest all the places are 0. Rest all the places are 0. Because we are dealing with the SOP form, so I have to group only the ones here. I have to group only ones here. Okay. So if I group the ones, the possible or can say maximum size group is quad here. So maximum size group is quad here. This is the quad. This is the quad. And second, for these two ones, we have one pair. We have one pair. So for this particular quad, I will have the F1, which is equal to, now we'll simply calculate it. So this particular quad is involving these two rows and these two columns. So for these two rows, if I look together, then B is not changing. Means B is 0 here and 0 here, while A is changing. Here is 0 and here is 1. So we don't have to write A, we have simply write B. But B is available in its complement form. So I will write here B complement dot. From these two columns, C is not changing while D is changing. So don't write D, simply write C. But C is available in its complement form. So I will write here at C complement. This is function 1 is done, or can say quad is done. Now for this particular pair, I have these two rows are involved for this particular pair. For these two rows, and can say one column is required or one column is involved. I'll simply clear these things. Okay. So, okay. From the black pointer, if this column is involved, means this column has C and D, both in its true form. So CD will taken simply as this. And for these two rows, B is available in its true form and not changing, while A is changing. So don't take A, simply take B. So we'll take the B. And B is dotted with CD because C is used once, no change concept of no changing here, and D is also used once. So we'll entirely pick this particular column, which is CD. CD. So this is can say F2. So for particular quad, we have one product term, and for particular pair, we have second product term, which is known as F2. So the complete function will be F1 plus F2, which is nothing but summation of two product terms. So finally, we will have one function F, which is sum of B complement C complement plus B C D. So finally, reduced form of function is SOP form of function, which is B complement C complement plus BCD. It is sum of two product terms, product term 1 and product term 2. Okay. So finally, I can say it is a reduced form. Reduced form. It is the reduced form. Possible reduced form. We cannot reduce below this. So this is the reduction of function if min terms are given. So steps are simply draw the K-map and fill the one at the place of min terms, and now pair can say grouping these min terms. The best possible group in this particular case is quad, and second is pair. From the quad, we will get the first product term, and from the pair, we will get the second product term. And finally, the answer has sum of both the product terms because we are using the SOP form. And finally, we will have the function B complement C complement plus BCD, which is the reduced form. So this is enough for this video. Thanks.